Thanks again for coming here today. I'm really excited for today's lecture because we are going to talk a little bit about user interface, and also we are going to have a hands-on session. This hands-on session, we will focus on the strategies that we saw in the last lecture. So we are going to see how to evaluate whether the strategy that we chose for our use case really works. And unfortunately, the code does not have a user interface, but we are going to see an example of a user interface today, and also best practices on how to create a good user interface. And so I'm going to start with demo from this book, Human in the Loop Machine Learning. It is a code that is available as part of the book. So then if you click on this link here, you will be directed to the GitHub webpage where you can download the code for this system, okay? Another thing is that it would be really nice if you could download the slides from today's lesson. So then you can download from CeADAR community activity feed. So the slides from chapter 3, they are already there, available there. So it would be nice because there are some links there that you can click and direct you to the code that we are going to use in our session today, and also all of the links that will be used in this session today. Yeah. The code is already there. Okay, so then you can download the slides from there. So then we can you can use the links that are available on the slides. So as I was saying, so then we are going to see this active learning system, which is a very simple system but very effective because the user interface has all of the necessary features that we need for a good annotation. In this system, the user is required to classify headlines, news headlines, into disaster-related or not disaster-related. So then the system asks the user to hit 1 for disaster-related news headlines, or hit enter for non-disaster-related news headlines. Okay, so very simple. Let's take a look at it. As I was saying, this is an open source example from chapter 3 and 4 from the book, Human in the Loop Machine Learning. And this example tries to classify news headlines into one of the two categories, disaster-related and not disaster-related, right? So then, as you can see here, the system starts with instructions, right? So here, so then it displays the number of instances that needs to be classified, and provides the instruction. Please type 1 if this message is disaster-related, or hit enter if not. The system also has the option to type 2 to go back to the last message, or type D to see the detailed definition of what is disaster-related, of what a disaster-related headline. And there is also the option to type S to save your annotations. So then let's get started. So then I've done some of the examples already. So then we have here please type 1. So every time a new headline is displayed on the screen, the instructions are printed, okay? So then please type 1 in if this message is disaster related, or hit enter if not. So Green's MP concerns about dangerous religious educations taught in public schools. What do you think? This is disaster related or not?
Not.
The last one here. What do you think, guys? Green's MP concerned about dangerous religious education taught in public schools. Is this disaster related or not? So I think this is not disaster related. So then I'm going to hit enter. Okay. So the next one, Rugby World Cup. Wallabies coach Michael Cheika feels for suspended Scotland players. Sorry. So is this disaster related or not? What do you think? I think this is just news headlines about sports, right? So then I'm going to hit enter, right? So Qantas defends Joyce pay rise, so not disaster related. Jet ski crashes onto boat ramp in southern Tasmania. So then probably this is disaster related. So then I hit 1, right? So then if I need to go back to the previous, so then I type 2, and then I enter 1 again, and then I go to the next again. If, as I said, I type D, there is an explanation of what would be a disaster-related headline, right? So I think it includes human, animal, or plant disasters, the response to disasters, natural disasters, and man-made ones like wars. It does not include criminal acts or post-response activity like disaster-related memorials. Right, so this is the explanation. So if I enter S, I save, and then the process is finished. Okay, so this is an example of very simple human in the loop active learning. And then, as I said, there are some tips that we should follow in order to create a good user interface. So then let's take a look at this one. As I said, first you need a description of the task, right? As we saw here. So every time a new headline is displayed on the screen, the same description of the task is displayed, right? So then this is important, otherwise the user can confuse whether to type 1 or to enter, to hit enter. And also it's important to have a go back function, like here, the go back button. So then if the user enter by mistake number 1, so then he can go back and then he entered the label, right? It's also important to have a description of what is disaster-related definition, right? So then this can really help the user to decide which label to add for each of the examples presented on the screen. So then this is also a very good idea to have this definition. And also it's also important to have a safe button. So then after clicking on save, the loop is finished, and then the user can start again in another time, right? The same task. So tips for a good annotation process. So then before annotation, if you are creating an active learning system, it is important to provide annotation guidelines, as I showed you here. That could be displayed on the screen, or you can also guide the user on how to use the system, right? It's also nice if you could carry out a practice session, show how everything works before really starting the annotation process. As I showed you, it's also important to have a go back option to allow the user to fix any possible previous errors. A description of the task on the screen. And also, if, for example, if you have many examples of the same category, and also, for instance, if you have many examples of disaster-related and many examples of not disaster-related, it's also nice to shuffle, because if you present more disaster-related before not disaster-related, so then when this can confuse the user, because it will probably annotate an example that is not disaster-related as disaster-related, just because it was just following a pattern, right? So then it is important to pay attention to these details. So then this could interfere in the annotation process, and this can bias your results, as the model will not be trained on real data, realistic data, right? And this can also influence the performance of the model, of course. Another thing that could also influence in the performance of the model is that if you have more than one person annotating the same data, so then you can calculate the disagreement between annotators. So then it would be nice if you could identify each annotator on your system, include a component in your code that allows you to identify between annotators. So then you can calculate the agreement or disagreement between annotators. If you don't really understand why the model is not really improving the performance, so then that's probably because there is a disagreement between annotators that is biasing the results. Okay. Another thing is that it's important for you to save the data that you annotated, so then you can also analyze in the future what was wrong with the data that was annotated by the users, and also try another round of annotation. As I said, also calculate agreements between annotators. So then this is also a good practice for your active learning system. So now, so I'm going to show you a code that I created using a data set that I downloaded from Kaggle. And this data set is, it's called YouTube comments. If you click here, you can download this data set, but it is also available on the, actually I forgot to upload this data set to the CeADAR community, but I'm going to send you the link, okay? So then you can download this data set, and then we will see how to evaluate if the strategy that we are using really works for our use case, right? In this data set, we see the relationship between the popularity of certain videos, YouTube videos, and the sentiment associated with each video. So there are more than 18,000 rows and 5 columns, but in our for our hands-on session, we are going to use only 1,000 examples. Okay. So then there are these columns here in the data set: video ID, the video identifier, the comment tag, the comment text, likes, the number of likes the comment received, and the sentiment of the comment. A value of 0 represents negative, 1 represents positive, and 1 represents neutral, and 2 represents positive sentiments. Okay, so in this notebook, Google Colab notebook, I'm going to present a code for the margin confidence strategy. If you remember from last class, margin confidence calculates the difference between the first most probable label, the difference between the first most probable label and the second one, right? Is the difference between the two. Okay, so then let's take a look at the Google Colab notebook. So what you can do with this code, if you want to run this code with me, you can just open the Google notebook and then go to File, and then save a copy in your drive, okay? So then if you save a copy in your drive, you'll be able to run the code with me. So then I'm going to start by installing the modules and also importing the relevant modules. Okay, so I will read the data set. As I said, there are more than 18,000 examples, but I'm going to use only 1,000 examples in this session. Okay, and then here with this code, I'm going to count to see if the data is balanced or not. So then for the we have more, almost half of the data set as positive example, as positive texts, right? Positive comments. In the other half, we have neutral or negative. So it's unbalanced data set, right? So let's see what happens. So then if I click here, if I click here, you see that we have converted our labels, right, into a NumPy array. And this is will be used later on for our model training. But first I need to pre-process the text. I need to vectorize the text, convert into numbers. So then I extract stop words first. I do some stemming. I also convert all words into lowercase. And I also use TF-IDF vectorization strategy, right? Stemming means that I'm going to reduce all the words into its base form, right? So then, for example, if a verb is it's inflected like R or M, so then the base form would be B, right? So then this is what steaming does. And it is important also to convert all the words into lowercase, just because we know that Python is case sensitive, so then we can avoid any problems in the future with this. And TF-IDF, it's a strategy for text vectorization that takes into account the frequency of a word in a text, okay? So this is what it was done here with this code. So then here, now the text is vectorized. So then we have now 6,244 columns, right? Because this is the number of words that we have in our data set. And then probably there are, for each sentence, this strategy adds like a kind of weight to each word in the data set based on its frequency. Okay, so this is like the basic explanations, but if you Google TF-IDF, you are going to find a much better explanation for description of how this type of vectorization works. And here we have one hot encoding of our class labels, right? So then 0 is positive, 1 neutral, and 2 negative, okay? So then here I'm going first to concatenate the data sets, X and Y. And here I'm going to remove 100 examples that will be for our that will be used for testing our models, right? And here I'm going to separate into training test, right? X train and Y train, X test and Y test. I did that manually because I'm using different data sets for the test set, because this one here, this data set that I'm creating, the X-train data, is the data set that does not contain the test data. And here is the data set that contains the test data, which is between the row 300 and 400, okay? Did you understand? Was that clear for you? Yes? Okay. So now that I have my train and test sets, I'm going to check their size. So then, as I said, I separated 100 rows, 100 examples to test our model, and the remaining 900 is to train our model, okay? But if you remember, in active learning, especially the pool-based structure, architecture, usually we have a small data set and also a pool of unlabeled data set, right? So in our case, we have actually 900 labeled data, but then we are going to simulate this scenario, okay? We are going to train first, considering only 300 examples, which represents our small data set, and use the remaining 600 examples as our pool of unlabeled data sets. And then we are going to use the model trained on 300 examples to predict the labels of the 600. Okay, is that clear for you? Okay, so then So then here I have separated. So I'm going to train a support vector classifier using one vest to rest classifier. If you're not familiar with this algorithm, you can click here. So if you click here, you see that one versus all consists of fitting one classifier per class. Okay, so then this works very well with multi-label problems or multi-class problems. In our case, we have a multi-class problem because the model needs to needs to choose between three options, right? Neutral, positive, and negative. So then this is a multi-class problem. And one versus rest classifier is very good strategy in these cases. Okay, so I'm going to start with 300 and let's see what is, let's evaluate the performance. So the model will be is trained then on only 300 examples. So probably the classification report does not show a very good performance. Let's see. So as you see, the area under the curve is 0.52, so then it's very low. And if you notice here, there are two labels that were not detected by the model, probably because these labels, they are not present in the training set, or very few of them are present in the training set. So then our strategy probably will help us to collect more of these two labels here in order to improve our model, right? So then let's use here. So then the next step would be to predict the unlabeled examples using this model here, this model that was trained on only 300 examples. Okay, so then if you look at the shape, we have 600 predictions, right? It's a NumPy array with 600 rows and 3 columns. So if you print here, we have the predictions for each of the rows, right? Okay. So far, so good? Yes? Guys, if you don't understand anything, please let me know, because I know this is complex stuff. Okay, so now the next step is to associate the predictions with the index of each example in the data set. So then we can see this association, we can use later on to see the indices that contains uncertain predictions, right? So this is, I'm associating here. And then I create a dictionary. So as our pool starts at number 400, so then this is the predictions of example 400, okay? Those are the predictions of example 401 and so on, okay? So this is the dictionary that I created. So then if you look at the length of the dictionary, there are 600 examples in our pool, right? Now, this is the important part. Now we are going to use this code to select the most useful instances from our pool using margin confidence prediction, margin confidence strategy, right? So as I said, in the margin of confidence strategy, what we have is we subtract the most probable probable label from the second most probable label, right? The highest probability, the first highest probability from the second highest probability. And then these results we subtract from 1, right? So then we get, this is how we get the margin confidence. And then we sort, we rank order the scores with the highest scores first, right? So then if we see here, we have the highest score is associated with the example 556. So then if we had here a human in the loop, so then the first example presented to the human would be example with index 556. The second would be the example with index 476, okay, and so on. So, so then I just get the indices, then I add to a list here. If I click here, so then I add the indices to a list, because we are going to use this list to reorder the initial data set based on these indices here. So then I'm going to show you an example. So what we have now, we have all indices, the first 300 indices, they are in the rank ordered, right, in ascending order. So then we see here that it finishes on 299, right? And the rest is ordered by in terms of utility. So then this is the indices of our initial data set, and those are, and the remaining indices are the indices that were selected based on our margin of confidence strategy. Okay, so then these indices will be used for us to reorder our data set. So then if you click here, so then until index 299, so then I'm going to show from, I don't know, 219 on. So then we start here from 290 on, and then we if you can see here, it's not sorted, right? Because we have 848 before, sorry. Actually, it's sorted, but there are some gaps between the examples here, right? So then if I'm going to show from 299 on, we will see it's not sorted. It's sorted actually by utility, not by index, right? If you look here, we have 556 before 476, right? That's why this is here, because it's sorted by utility. So again, now I create a new train set with X and Y. And then I retrain the model on the new data set. The new data set was created from this sorted by utility data set that I just created here, the data merged new. If you look here, data merged new, right? Now I'm going to retrain the model. So in the first time that we trained the model, it was using 300 examples, right? Which represents our small data set. Now I'm going to retrain the model using the initial 300 plus 1,000 examples that were selected based on the margin of confidence strategy. So then in total, we have 400 examples. And then we will see the performance. Of course, the performance will increase because I'm going to, I'm increasing the number of examples, right? So then before we had area under the curve with this score here, 0.52. And then with 100 more examples, we increase this score for 0.57, right? But then if we compare here the same model without using strategy, using random examples, right? With 400 examples here, let's see if we get the same score. So this is, there is no strategy here selected when training this model. Let's compare the performance with the model trained with using the strategy. So you see, it's a little bit lower, the score, the AUC score. And now, so we can see here that the model is not detecting negative and neutral labels. But if we look here, at least the negative label was detected using the strategy. Yeah. So let's see with 500. So let's retrain the model using 500 examples, the 300 initial plus 200 random, and then compare the same model using the strategy. So this is random selection. So with 500, it was already able to capture this label here, the negative label. And let's see the AUC score. It increased to 0.6. Let's see again here, using the strategy. 500 and 500. Yeah, so you see, with 500, there are more, it was able to select, actually to train using this label, the neutral label. Let's see if the score, AUC score increased. It didn't increase, but then, you could see here that the model was able to be trained and also to return the precision of the 3 labels, right? While here you only have 2, right? Because it's biased on the positive, the majority class. And here is no longer biased on the majority class. right? So let's train again using 700 examples. Let's see the difference between the two. Here, again, random selection, the 300 initial plus 400 based on random selection. Yeah, now it takes a little bit longer, but it's not that long, don't worry. Let's print the classification report. Yeah, it increased a little bit, and it was already labeled to detect all the labels here. The model could detect all the labels here, right? Classify all the labels. So those are the micro and macro F1 scores and 0.6 to 1 AUC. And here we have, let's say, 500 again, using the strategy, the 300 initial plus 400 using the margin of confidence strategy. Yeah, the scores are better. And here we see a difference here already in the AUC score, 0.63, and then here 0.6 to 1, right? So then using the same amount, the same number of examples, I get a higher score using the margin of confidence strategy, right? So then if I train here, let's see if I increase to 800, if I get I increase AUC score, if I increase the number of examples here with the random selection. So then we can see how many labels I would need to get that performance with 700 examples. How many examples I would need more to get the same performance with 700 examples. Takes a little bit more time. Okay. Even with 100 more examples, I didn't get 0.63. Let's see with 50 more if I get. Even the scores here are lower compared to this one. The F1 scores here are lower. Okay. So then here, even it decreased, probably because there are some data that is not really contributing to the performance of the model. Probably this is noisy data. So then, yeah. So then we can conclude from this from this example that we could, with less examples, 150 less examples, we could achieve a higher performance compared using the margin of confidence strategy compared to random selection. Okay, so with 150 examples, with less 150 examples, we could achieve a better performance compared to 150 examples more. Okay? Does that make sense for you? Okay, so now, do you have questions or observations here? No? Okay. Now, what I want you to do is, I have here, if you look at the slides that you just downloaded, I'm going to share with you again. If you click here on list confidence, you will be directed to another notebook with the code for the list confidence strategy. Okay, it is using the same data set. Everything is the same, only the strategy that is a little bit different. That's different. Actually, it's the normalized list confidence. What I want you to do is to run that code. I'm going to share again. To run the normalized list confidence strategy code and see if the list confidence strategy also works for our use case for the YouTube comments data set or not, okay? What you can also do is to use different parts of the data set. So for my code, I use the initial 1,000 examples. So then you can change that. You can use the initial, I don't know, 2,000 or from 1,000 to 2,000, for instance, here, right? Or from 3,000 to 4,000. Okay, so then I would like you to compare and see what really works in our use case, and if the list confidence strategy works compared to the margin of confidence. I have a question here, just a moment. Yeah, the Connor said it is normal. Yeah, sometimes it takes some time for you to see a difference, unfortunately. But sometimes it's normal not to see a difference between some parts of the in some parts of the selection of the useful instances, because the useful instances, they are hypotheses, right? They are hypothetical, more useful than other ones, right? So that's why we need to test more than one strategy for our use case. Yeah, it is worth trying with a slightly larger range again. So yes, it is. That's why sometimes I try using 50 every 50 examples, right? Because the idea is try to reduce human effort as much as possible. So then if you notice that with only 50 more examples, or even less, like 20 more examples, we get the same performance compared to more examples based on random selection. So then it's worth, maybe it's worth stopping, or even start trying until the model stop improving the performance. Because of course we will have some examples that really don't contribute to the performance of the model, and they will be at the bottom of the pool, right? So then if you train the entire model, and then you see that the performance sometimes decreases, this is because this means that the remaining examples, they are noisy examples. They are not really contributing to the model performance, and they are actually sometimes confusing the model. Okay, this is what we call overfitting, right? Because it's learning noise, not really learning what needs to be learned. Okay. So this is what I wanted to do, and I would like for this session, if two of us, at least two of you, could share your results with me and with your colleagues, that would be really nice to see what we get using the least confidence strategy. And then what you can do is just to tweak the code a little bit. Here, run the code you can tweak when training with random and training using the strategy. Let's see. So then you can start here with 300, right? And then run the rest of the code. I'm going to. And then also tweak here again, retraining the model, right? From 400 on. Okay.
Okay. The last thing I tried there, I've downloaded it into C users Connor Learning NLP datasets. So I've renamed it NLP datasets. And that doesn't work either. But what I had was, what you had the content. I had, sorry, this is your original one.
Because, name PD first. It's because maybe you didn't download the pandas.
Oh, I did that. Yeah, see the tick there. It was very fast.
Okay, pandas SPD.
Yeah.
Yeah, but then look here. You see the error says no. Scroll down, please. I've seen that.
I think that's like it can't find the local file. Now, if I do this.
Okay, but what if you removed C?
Just like that?
No. Okay. So what you have to do is.
Yeah. Sorry. Yeah.
Okay. Click. You see that folder symbol on your left side in the panel. Yeah.
That one. Yeah.
Oh, yes. Open, and then click on the file with the arrow inside. Yes, this one. This one. Then you upload there.
Okay. Oh, okay. Now it'll probably overwrite what I've uploaded already, but that's okay.
No. You just upload it. Just select the file, and then click on it. Open.
I'll go to the folder.
Okay. Go to the folder where the file is.
I think I put it in learning. There.
Okay. Click on it. Click.
Double click.
Yes.
Oh yeah. Okay.
Open. Okay. Just click OK.
All right. So it's down here. It's loading up. Yeah.
Yeah. Is your drive mounted? Did you just click on the folder? Yeah. This one. This one. Yeah. Click here. Yeah. Okay, just then run the cell drive.mount.
Okay.
Okay, connect to Google Drive.
This is fantastic.
Yeah.
Yeah.
So then you enter your password and everything. Allow. Great.
Good.
So then now your drive is mounted, right? So
Yeah.
then just click on the left panel, Drive. You can see the folder Drive. Click on it. And then you have to navigate until your
NLP notebooks.
Yes.
There. So that's probably all I needed to do.
Yes.
If it was uploaded already.
Can you see the three dots on the right side?
Yes.
Just then copy path. Yeah.
And that goes in
So
here, I
then-
guess.
Yes. This, but then you have to change instead of load data, delete load data, the word load data. Yeah. Then it's PD, DF equal PD.
PD.
Yeah.
Instead of
pandas.
load data.
Yeah.
Is that this is up here?
Delete. Oh yeah, it's already there. It's already
inside the function.
Oh yeah, great. Yeah. Oh yeah, the function is load data. Just run it.
I chose 5,000 to 6,000. Well, actually, 5,000, 6,000 okay.
Yes, great, worked. That works.
Now,
Great.
fantastic. Okay. I probably should have done this first, but look, it doesn't.
Yeah. So then, so you don't need anymore to. You can run all the other cells. If you want to do that with me right now, I don't mind.
Oh, wow, cool. Thanks. Yeah. Okay, I'll go with this. Well, we should be getting it.
This is just for you to check. Now, positive, it's unbalanced.
Very, yeah.
Yeah.
Okay. Yes, and this is like that. You had 0 to 1,000. So I remember.
This is one-hot encoding. This is just an NumPy array, and this is the preprocessing steps.
Okay, you're talking about the stemmers, yes. Okay, so if we have, say, some of our content is from our contact center and people phone in and they might be saying they want to cancel. Yeah, we'd have to train it up, I guess. Yeah. There's obviously positive, negative, neutral, but we also have somewhere people are saying we want to cancel something or alter. They might mind. So people can have appointments for that, and they might say, "No, I want to change my appointment." So we only have that on the where they're coming from and going, what date they're coming from and going to in the text. In it, so it might be brilliant to say, is this like a change of appointment or a cancellation? Yeah, I know it's only 2, but okay, concatenating date frames, yeah.
Yeah, you can click on the cell to open it. Just click on it. Yeah. Just to visualize. Now the text is vectorized.
Right. Yeah. And all of that. Okay, yeah. So moving on. Okay, so this is the 100.
100 just for testing the model.
300, 400. I can leave it at that because it's a different. It's 5,000, 6,000, not.
Yeah.
Okay, separating Y from X. Yeah.
Yeah, well, you'll see that the least confidence strategy is not as good as the margin confidence that I showed you.
Yeah. The least confidence was last week's one. I mean,
of all the strategies I presented in last week, the least confidence is one of the strategies, but it doesn't take into account 2 probabilities. It takes into account only one probability, the highest probability.
Sorry, unknown label array. X-train init. Did I miss one up above? X-train init. Capital X, capital X.
Try to run again. Wow. X-train init, Y-train init. 300. Wow, that's big.
Did I only pick 100? Is that why? This is X init is 300 to 400, and that's 300 to 400.
Yeah, it's because actually you picked from another part of the data set.
Oh, right, okay.
So then it has to be 100 from that part. And
300, 400. Yes, of course. Yes.
Because
Okay.
I picked the initial 100, 1000.
Yeah.
No. Let's see. Let me check the first cell. Scroll up, please. Because those are the numbers of the indices.
300, 400.
No, the first cell. So which part of the data?
Way back up the top. Okay, 5,000.
5,000 to 6,000. So then you have to select 100 between 5,000 and 6,000.
So in here as well?
It could be, I don't know, from, I don't know, 1,100 to 1,200. No, 5,000.
5,000, yes, okay. Okay, 5,200, 5,300. And that's for the indexing as well, I guess.
Yes.
Oh, sorry, 5,3.
Same, yeah. Well, thank you very much.
Thanks very much, Natalia.
Okay. Bye.